All right. Greetings, everyone, and welcome to UNC Universe Week. We are so excited to have you from all across the state and maybe beyond. Today's program is part of the North Carolina Science Festival, which is a statewide celebration of STEM that happens every April all across North Carolina, many events happening all over. This morning, we're pleased to be joined by our very own Amy Sale from UNC's Chapel Hill Moorhead Planetarium and Science Center. In just a moment, we're going to hand things over to Amy. But first, because we are on a virtual media, I did want to go over a few quick reminders. For those of you that are joining us from Zoom, please use the Q&A feature for any questions that you may have for Amy today. You can also type in the chat if you have any comments. If you are joining us from YouTube Live, welcome. You can submit any questions that you may have by email to ncscifest@unc.edu. And that's how we will be taking questions today. We also want to give a special shout out to our featured classrooms, all from Jonesville Elementary School in Jonesville, North Carolina, in Yadkin County. Go Blue Jays. We are so happy to have all of you here with us. Ms. Sizemore's class, Ms. Foster's class, Ms. Law's class, Ms. Freed's class. We are so happy to have all of these Blue Jays that are waiting for Amy to give her talk. And so now that we've gotten all of those introductions and little housekeeping things out of the way, I am again pleased to announce our presenter day is our shining star from Moorhead Planetarium, Amy Sale. Take it away, Amy.
Thank you so much, Kim. So hello, everyone. Good morning. I'm Amy Sale, an astronomy educator at Moorhead Planetarium and Science Center. We're located on the campus of the University of North Carolina at Chapel Hill. Maybe some of you have been in our building and been to programs with us. We also serve the state through our summer camp programs, mobile lab vans, and we also produce the annual North Carolina Science Festival. Our mission is to help people better understand science, technology, and health, and we do this through engaging learning opportunities like this live virtual program. Okay, so here's the plan. I am in just a moment going to show you the night sky from North Carolina using planetarium software. We will find things in the sky, planets, stars, constellations, or patterns of stars, things that you can see for yourself in the real sky on your next clear night. And along the way, I hope you learn how the sky provides you with a compass, a clock, a calendar, and if we have time, we might even talk about how the sky provides us with a time machine. And so remember to ask your questions along the way. And what I'm going to do now is share my screen, and I'm going to be showing you a planetarium software program called Stellarium. And this is free software. You can download it yourself from stellarium.org. And there's also a web-based version if you don't like to download things. And so take a look at this sky that I'm showing you. I've got it set up for Chapel Hill, North Carolina, but if you're watching from anywhere in North Carolina, it's essentially the same sky. This is how it looks right now. And let's just make some observations. So look at your screen, see if you can find the ground or the grass. See if you can find the blue sky. See if you can find the horizon. The horizon is where the sky meets the ground. And it looks kind of weird in the stellarium view. It's like curving. And what's going on, I mean, when I go outside, it doesn't look like that. But what's going on is we're taking this three-dimensional thing, the sky, it's all around you, it's above you. And we're taking as much of it as we can and trying to represent it on a flat 2D screen. And so that's why things look a little distorted. It's so we can show you more things in the sky. Now, if you look closely at the horizon, you may have noticed some red letters. I see an E, I see an S down at the bottom, and then over to the right of the screen, you might see a W. And you've probably figured out those are the cardinal directions, east and south and west. And there's even directions in between, like SE for southeast and SW for southwest. And you might wonder, well, where is north? That seems like an important direction. And the answer is it's behind you. So that's why you're not seeing north represented, but we'll see it. We'll see it in a few minutes. As for the top of the sky, in real life, it's over your head. And here in the stellarium view, it's probably close to the top of the screen right there. Okay, So stellarium, it may be difficult to see depending on how your screen is, but it shows you where you are in the left lower part. It tells you we're looking at the sky from Earth. I've got it set for Chapel Hill, but again, anywhere in North Carolina, this will apply. And it also shows you the date, 2022. If you're watching this live, it is April 8th, and then also shows you the time. And then to the right of that, that's just some time zone information. So my first question for you is, it's daytime. Do you see any stars in this sky? I see one. It's a really bright one. It's so bright, it keeps us from seeing all the other stars that are above the horizon right now. And that is our daytime star, the sun, the one star that's in our own solar system. Okay, you might look around. Do you see the moon? Sometimes the moon is up during the daytime. And in fact, it will be up in the sky, but a little bit later today. So it's not represented in the sky right now. It's still roughly about 9:30 in the morning. Okay. And if we want to see more stars, we are going to have to get this really bright one below the horizon. So we're going to do a little time travel here in Stellarium. And I'm going to manipulate the software program to make the sky go a little forward in time. Let's go a little bit faster. And if you look really, really closely, you might notice something's moving. So the sun is moving. It's moving across the sky. We're speeding up time. We should get the moon soon because the moon is rising later this morning. There comes the moon. The moon is 1/4 of the way across the sky from the sun. And in fact, the moon's phase right now is first quarter. Okay, so I want to pause for a second and let's consider what's going on. So we're going to pause here right before about 5 p.m. And if you're looking at the clock, if you're able to see the clock, it says 16:49, and you might wonder, what is that? So it's a 24-hour clock. So once we got to noon, that was 12. When we went to 1 p.m., the clock said 13, 2 p.m., 14, and so on. So 24-hour clock. Okay, so let's consider what just happened here when the sky looked like it was moving. Is it the sun really that's the thing that's moving, that's making it look like the sun is moving across the sky? You probably know that it's actually something else that's moving. We live on a spinning planet, Earth. And you can actually do a demo in a moment. What I want you to do is I want you to consider your environment where you're sitting right now. Look around, make sure there's nothing to trip on. You want to make sure there's no cords or anything in your way or a table in your way. And if it's safe for you to do so, and if you're able, I invite you to stand up right now. Stand up. You're going to pretend that you are planet Earth. And then I invite you, those of you in classrooms, make sure your teacher is okay with this, to turn around slowly on the spot. So just spin around slowly on the spot. Keep your eyes open while you do this and make observations about the room around you. So as you slowly turn, can you notice that it looks like the room is turning around you in the opposite direction? Okay. And so when you're ready, go ahead and face the screen again, and then safely take your spot again, sit down again. So you were pretending to be Earth, and the room was like the sky moving around you. So we live on a spinning planet. Earth spins just like a clock, and it makes the sky appear to turn around us, kind of like a clock. Okay, so here's a question. You all probably took, I'm guessing, about 2 seconds to spin around one time. I wonder if you all know how long it takes the real Earth to spin around. I'm betting many of you do. It's one day, it's 24 hours. And so Earth spins every 24 hours, just like a clock, and the sky appears to move around us. That's why the sun moves around us during the day. And that's why at night, the other stars look like they're moving as well. Okay, so let's see if we can get that sun moving again. And so the sky is like a clock. It's also like a compass, meaning that you can tell direction just by looking at the sky. And so take a look at where the sun is moving as it moves towards the horizon. So it's going to be setting, and take a look at what direction it is setting. And it's setting more or less in the west. So you can tell direction just by sunset. Okay, Get ready. It's getting dark. Watch for the bright stars to come out. Oh, I think a satellite just whipped by. So I'm going to pause us right there. So it's roughly 9:15 p.m. I've set the sky to roughly an hour and a half after sunset. Sunset tonight in Chapel Hill is 7:43 p.m. So roughly 7:45. It might be a little earlier or later if you are to the east or to the west of us, respectively, but it's roughly the sun is setting about 7:45 tonight. So you have to wait a while after sunset to get a dark sky. So this is roughly an hour and a half after sunset, or roughly 9:15 p.m. The moon is still in the sky. It's first quarter, which means that it's going to be up by definition in the afternoon and in the evening hours. Okay, so I mentioned that the sky is like a compass, that you can tell direction just by paying attention. So we already used the sun to tell direction. We know that the sun set more or less in the west. But now it's dark and we can't see the sun, and maybe we still want to know directions. Now, when you walk outside in the real sky, you are not going to see any red letters. I have checked, they are not there. So you need another method to figure out directions in a night sky. So we can use a star called the North Star to help us figure out north. And then once you've got one direction, you can figure them all out. Okay, if we want to see the North Star, we're probably going to need to face away from the south. So what we're going to do is we're going to imagine that we're turning, and then we're going to look to the north. Okay. So let's see if we can figure out which star is the North Star. So here's a hint. Here's one thing that it's not. It is not the brightest star in the sky. It's not famous for being bright. The North Star is famous for being in the north. Okay, so Stellarium does like to mark bright stars with bigger dots and with labels. So you can kind of see that some of the brightest stars in the sky right now, Capella, Betelgeuse, Rigel, Aldebaran, and so on, none of these stars are in the north. So the North Star has got to be one of these ones that are over this red letter N here. But how are we going to figure out which one? Well, we're going to use a technique called star hopping. Star hopping is where you take one thing that you already know in the sky and you use that to hop your way to something else that you don't yet know. So let me teach you a star pattern, and you'll know it, and then we'll use it to star hop. Okay, so the pattern we're going to use is the Big Dipper. And some of you probably already know the Big Dipper. So if you see it, feel free to point to it on the screen, help people around you know where it is. The Big Dipper consists of 7 fairly bright stars. 3 of them are in a handle, and 4 of them are in a bowl or a cup. So I'm going to circle the general area with my pointer and see if you can make out something that looks like a Big Dipper, or maybe it looks like a soup spoon or a skillet with a long handle. Maybe it looks like a drinking gourd. Maybe it looks like a camel, an elephant, a plow. People all around the world have looked up at the sky and they have seen various things. So I'm going to show you what I see as a Big Dipper. So I see 1, 2, 3 stars in the handle, 1, 2, 3, 4 stars in the bowl. None of these stars is the North Star, but 2 of them point to the North Star. So the pointer stars are the two here at the side of the bowl, go from the bottom of the bowl, go through the top, and keep going until you hit a fairly bright star, although not the brightest in the sky. And that star is Polaris, the North Star. And this star is also part of the Little Dipper, which maybe you can see here. So let's outline both the Big Dipper and the Little Dipper. The Big Dipper is part of a larger pattern called Ursa Major, the Big Bear. I think it looks, frankly, like an ironing board. I don't know. What do you all see there? What does this look like to you all? I wonder. Okay. Maybe you see a dipper though. So there's a handle, there's the bowl, and then this star, Merak, goes through Doobie, and then you do your way all the way to Polaris, the North Star. And this star happens to be the North Star because it's sitting over Earth's North Pole. We got lucky that there's a star there. It's not exactly over the North Pole, but it's close enough to do the job. So if you're over the North Pole, what that means is that this star, it's over our planet's axis of rotation. So it acts like a pivot point in the sky around which the whole sky turns over the day and over the night. So Polaris stays at the same spot all the time, as long as you stay at the same latitude on Earth. Okay, so you can see it's right over that red letter N. And these star patterns you might be familiar with as being parts of constellations called Ursa Major, the Big Bear, and Ursa Minor, the Little Bear. But again, different people have seen different things in the sky. So if you want to see something else in the sky, that's fine. I'm fond of the Southern Paiute story where Polaris is actually seen as a mountain sheep that got to the top of a really tall mountain and couldn't get down again, was turned into a star. And then all these other stars are other mountain sheep endlessly circling him, trying to find their way to the top of the mountain to join their friend. Okay, so that is some of what's visible in the north. So this is how you can use the sky as a compass. Use the sun to tell direction in the day, rises in the east, sets in the west. You can use the North Star to find directions at night. All right, and I'm going to ask Kim if there happens to be any questions or comments in chat that I should know about.
We currently do not have any questions in the chat, but that's a great reminder that at any time, if you do have a question, feel free to go ahead and type it in and we'll make sure it gets answered.
So you can put if you're watching on Zoom, questions can go into the Q&A feature. And if I'm asking you a question and you want to type anything into the chat and answer it for me, I'm happy to see that as well. Kim will draw my attention to it. And then if you're watching on live on YouTube, email us at ncscifest@unc.edu and we'll get those questions that way. So we're going to turn back to the south because frankly, most of the action in our northern hemisphere sky is in the south. So we're going to take a south view again. And let's look at what we've got. So we've got the moon here. And I'm wondering if any of you all have seen the moon in the real sky. Guessing many of you have, maybe most of you. Maybe you've seen the moon at night. Maybe you've seen the moon in the daytime. And by the way, if you have never seen the moon in the daytime and it's clear for where you are this afternoon, go out and look for it. And let me show you what it will look like. Oh, it looks like the moon is hanging out in Gemini, the twins right now. So let's zoom in on the moon. Let's go a little bit closer. Okay, and that is what the moon looks like today. So let's make some observations about it. What do you notice? You might notice, you probably know it's actually a sphere. It's like a round ball here, but we can't always see all of the side that's facing us. And those are the different moon phases, that changing appearance of the moon over the month. It's actually the moon's orbit around Earth that creates those changing appearances, the different phases. And it takes about a month for the moon to go to orbit the Earth. That's why it's called month, by the way. It comes from the word for moon. So you can see here the terminator. This is the line where the daytime side of the moon meets the nighttime side of the moon. You might see some of these dark patches, the Maria. If you're looking closely near the terminator, that's the easiest place to see craters where the moon has been hit by rocks. And this phase, again, is called first quarter, which if you've learned fractions, that might be a little bit of a confusing term because it's not a quarter of it that's lit up. It's actually half of the moon that's being lit up. It's called first quarter because of where it is in its orbit around Earth. It's 1/4 or 1/4 of the way around. It was also, if you notice, 1/4 of the way across the sky from the sun. Okay, so let's zoom back out. Oh, before we zoom, let me mention some shameless history about Moorhead Planetarium and Science Center. We trained astronauts back in the 1960s and 1970s in our planetarium dome. And they learned about celestial navigation, how to tell just by looking out the window of their spacecraft, how their spacecraft was oriented in space. And some of these astronauts that we trained include people who have been to the moon. So if you've ever heard of Neil Armstrong, Buzz Aldrin, first people to walk on the moon, they once trained at the planetarium where I work. Okay, let's zoom back out and let's clear that off a little bit. And then we're going to swing south again. Let's get this back. And you can kind of see how I can manipulate stellarium in different ways. And let's get exactly south. Let's make the view a little bit. Well, we can see a little bit more there. Okay, so let's now, we've considered how the sky is like a clock. It's always moving over the day and the night because of Earth's rotation. It's like a compass. You can use the sun, the North Star to tell direction. It's also like a calendar. And what I mean by that is that because of Earth's orbit around the sun, it takes, how long for Earth to orbit the sun? You may know this, a year. So everybody think right now about how old you are. How old are you right now? Are you maybe 6 years old, 8 years old, 9 years old, 11 years old, 50 years old, 80 years old? However many years old you are right now, that's how many orbits you have made on Earth around the sun since you were born. So if anybody's having a birthday today, happy completion of your latest orbit around the sun. Okay, so as Earth is orbiting the sun, we see a slightly different view of the Milky Way galaxy that we live in every single night as Earth moves around the sun. So that changes which constellations it's best to see at different times of the year. So right now, astronomically speaking, the season is spring in the Northern Hemisphere where we live. So we've got a nice view of spring constellations. But if you go out early in the evening, like we are right now, it's just an hour and a half after sunset in this April 8th sky, you can still see winter constellations. So let's look around right now and see if we can find the most prominent of the winter constellations. So I'm thinking of Orion the Hunter. Okay, so the easiest way I think to find Orion, if you don't already know him, is to look for Orion's belt. So we're going to look for 3 bright stars right in a row. And remember, stellarium marks brighter stars with bigger dots. So look for some dots that aren't too hard to see. 3 of them right in a row. And I'll give you a hint. They kind of look like they're hanging out in the southwest, maybe west-southwest. So probably towards the right of your screen, maybe about halfway up your screen. And I'm going to circle Orion here. And Orion's belt are these 3 stars that I'm pointing out with my pointer. And then if you want to try to picture the hunter, it takes a little imagination, but this is his belt. He's got 2 shoulders. That bright reddish one is Betelgeuse. He's got 2 knees. That bright one is Rigel. And then let's click on one of these stars and see if we can get a picture of Orion there. There's Orion. He's often depicted as kind of holding up a bearskin or a shield and like wielding a club over his head. And Orion, let's meet some of his friends. If we go down and to the left, from his belt, we get to the brightest star in the night sky, Sirius, the dog star, part of Canis Major, the big dog, one of Orion's hunting dogs. He's also got another hunting dog. It's the little dog, Canis Minor. It's a very little dog. All anybody ever bothers to connect are these 2 stars right here, Procyon, that other star right next to it. But somehow the artist here managed to imagine a dog in the sky. And then I think it looks more like a hot dog since it's just like a line. And then if you go up and to the right from Orion's belt, you get to the eye of the bull, Aldebaran. So there's Taurus the bull. And if any of you happen to be watching from Durham, North Carolina, you should consider this little star cluster right here your stars. Because these stars, this is the Pleiades. It's a star cluster, also known as the Seven Sisters. M45, it goes by a whole bunch of names. And Onondaga culture, it's Ukwada, the 7 star dancers. The Monachi, it's the 6 onion-eating wives. If you live in Durham, this star cluster is on your city flag. And it's very appropriate because this star cluster is within the constellation of Taurus the bull, and Durham is known as the Bull City. So good choice. The star cluster is also known as Subaru in Japan. So if you see a Subaru car in front of you, or in traffic or in a parking lot, take a look at the emblem on the car and you will see stars. Okay, and there is a story. I'll tell you a really brief story. This comes to us from Greek myth about why winter is the best time to see Orion. And this is how it goes. Orion was a mighty hunter. He was such a great hunter, and he was really boastful about it. He bragged one day that no beast on earth could ever escape from him. And that was asking for it. So the gods sent a tiny scorpion to prove Orion wrong. And that scorpion stung Orion on the heel fatally. But before Orion died, he got his revenge. He clubbed the scorpion to death. So it was like this double murder. And then the gods placed the 2 enemies on opposite sides of the sky so they'd never see each other again. And that, according to Greek myth, is why you see Orion best in the winter and the scorpion best in the summer. And if you're looking around the sky right now, you're probably not seeing a scorpion because in fact, it will not rise until Orion sets. So we can see it, but we'll have to stay up later. Okay, so I'll interrupt again just to encourage you to ask questions if you have any. Kim, let me check. Do we have any questions yet?
We did have a question come in that you partially answered. The question was, how do people use the sky to make a calendar? You definitely touched on that, but if you have anything else to add to that, that would be great. That question came from Mrs. Sizemore's class.
Okay, thank you to the student in Mrs. Sizemore's class for that question. Yeah, so the scientific explanation, of course, of how the sky is like a calendar doesn't have anything to do with hunters and scorpions. It has to do with Earth's orbit around the sun. So as we orbit the sun over the year, we see different star patterns better. The nighttime side of Earth faces a slightly different part of the galaxy. And so that means that the stars on average rise and set 4 minutes earlier every night. So we've still got Orion in our spring sky, but only early in the evening, and he's going to slip below the horizon as the night goes on. And we're starting to get a view of spring constellations. So I wanted to introduce you to a spring constellation called Leo the Lion. And the easiest part of him to find is this backwards question mark. So if you look where I'm circling, there's a backwards question mark in here. Let's see if you can find it. And the bright star at the bottom of the question mark is called Regulus, and it's the heart of the lion. And again, not everybody has seen a lion in this part of the sky. Different cultures have seen different things. I went to a wonderful presentation last night that talked about some of the Ojibwe constellations that have been seen in the sky. And this was seen as tail of an animal instead of the head. And Leo the Lion is a really prominent springtime constellation. And then let's see how we're doing on time. Let me mention how the sky is also like a time machine. So I said the sky is like a compass, clock, calendar. It's also like a time machine. What I mean by that, I actually mean this fairly literally, not just metaphorically. So the idea here is that everything you see in your own room, in your own classroom, you see because it either emits or reflects light. And that light takes time to get to your eyes. Now, when you're, looking at your teacher across the room, we're talking nanoseconds. It takes very little time for the light reflected off another person to reach your eyes. But when you look into the sky, things are really far away. And even traveling at the speed of light, that light takes real time to get to your eyes. So think about this. Does light move quickly, slowly? Fast, right? Fastest thing in the universe, 186,000 miles a second. Okay, so the moon, for example, is more than 186,000 miles away. It's about 240,000 miles away on average. It takes light from the moon more than 1 second to get to our eyes. So every time you see the moon in the sky, you're actually seeing it as it looked in the past, just over 1 second ago. Now the moon, probably doesn't look different from second to second generally, but still, that's kind of cool. Planets, which by the way, we haven't seen any planets yet. There are no planets in the evening sky. We'll get some in a moment. They're light minutes to light hours away. Stars other than the sun, they're light years away. So let me give you an example. Sirius here, the dog star, is between 8 and 9 light years away. So what that means is the light that you see from Sirius, and I hope you will go out tonight and look for it if your sky is not cloudy, you are seeing starlight that's between 8 and 9 years old. So if you happen to be 8 or 9 years old right now, you can call Sirius your birthday star. You look at Sirius, you're seeing light that's as old as you are. You're seeing starlight that left the star around the time you were born. Just to give a couple more examples, if you happen to be 11, Procyon is your birthday star. It's 11 light years away. If anybody watching this is 65 years old, Aldebaran is your birthday star. And then we've got, let me just do a few, some of the teachers out there might have some of these as birthday stars. Pollux is about 34 light years away. If you're 34, Pollux is your birthday star. If you happen to be about 51, or 52, Castor is your birthday star. And if anybody watching this is 79, you get to claim Regulus as yours. 36 or 37, claim Arcturus, which is in the constellation of Bootes, the herdsman. Okay, so what I want to do right now is I want to show you all the constellation pictures that we've got here. And let's see if I can get them to all come up. And if you see one that you like, let me bring up the labels. If you see one that you like, remember the name of it, because it might have an interesting story, might have a number of stories from various cultures. This is only one particular way of looking at the sky that I'm showing you. There are many different ways you can consider the sky. There is an international community of astronomers, the International Astronomical Union, which had a series of passed a series of resolutions in the 1920s and 1930, and they said, okay, we need to just agree on what we're going to call the constellations so that we can talk to each other around the world and know what we're talking about. So they made a list of 88 constellations and decided where the boundaries of those constellations were going to be. They did not make up these outlines in these pictures, though. People do those in all different ways. This is just one particular way that I'm showing you. And let's see if we can spin through the night a little bit. So we're gonna let the sky move again, just like a clock. And you'll notice things rising in the east and setting in the west. Really, they're all turning around that pivot point of Polaris, the North Star. Let's see if we can watch the Scorpion, Orion's enemy. Do y'all see it rising? Kind of just rose there in the southeast. So we're now actually getting a view. We've stayed up so late, 3 in the morning. We're getting a view of summer constellations. I'm going to keep you up till about 5:30 a.m. That's going to be roughly around the time when it just starts to get light from the approaching sunrise. Let me go just a little bit more here. Okay, so I wanted to show you this guy because if you are interested in seeing planets, you are going to have to either pull an all-nighter, stay up most of the night, or get up really early. But I'm guessing some of you watching actually do get up really early. So think about right now, when you get up, is it still dark out? If it's still dark out when you get up, and you don't have too many trees over to the east or southeast, see if you can find planets. Okay, let's see if I can clear things off just a little bit, and so that we can see the planets a little bit better. This is where all the planet action is right now. It is in the early morning sky, the pre-dawn sky. So you can see that Mars and Saturn kind of look like they're hanging out close together. Actually, Venus looks like it's hanging out pretty close as well. And Jupiter is getting ready to rise. It's not a good time to see Mercury right now. It's more or less in line of sight with the sun. So it's up in the daytime. And you might notice, hey, what's going on? It looks like there's a planetary pileup happening. Planets are always kind of lining up in the sky. That just has to do with, oh, look, here comes Jupiter. That just has to do with the structure of the solar system. Planets actually love social distancing. They are many millions of miles apart from each other. So while you all are thinking of your questions, let's zoom in and take a look at a few planets. So let's see if we can get Saturn here. Looks like Saturn is hanging out in the direction of the constellation of Capricornus, at least right now. Let's zoom in. Now let's see if we can get a little bit closer. So take a look. I'm sure you've noticed the big feature of Saturn is rings. So all the outer planets in our solar system actually have rings, but Saturn is the planet with the best ring system. And you can also see in this view some of Saturn's moons, like Titan, for example. And let's zoom back out. And let's take a look at, let's see if we can get Mars. Wonder what we'll see when we click on Mars. Oops, that's Saturn again. I'm trying to get Mars here. They're so piled up together. It's actually hard for me to get the right one. I'm trying really hard here. I know how I can do it. I'm going to do a search for Mars. See if that will help. Okay. Oh, there's Mars and hanging out with 2 of its moons. And people pronounce these moon names in different ways, Deimos, Phobos. The moon names actually mean fear and panic. Mars is named after the Roman god of war, and it does look reddish in the sky. Okay, let's zoom back out again. And let's take a look at Venus. Venus might surprise you when we zoom in on it. Let's take a look. It looks like Venus, by the way, is hanging out in the constellation of Aquarius, the water bearer. All right. What do you notice about Venus? I noticed that it kind of looks like our moon in that it's like showing a phase. It looks like it's roughly halfway lit up, not the full thing. So Mercury and Venus both go through phases from our point of view. And by making observations of those phases, you can actually figure out that Earth is not the center of our solar system, that we're actually orbiting the sun, and as are these other planets. So there's Venus. It's by the way, don't take a vacation to Venus if you can avoid it. It would be a terrible place to go. It's really hot. You know how like on a hot day in North Carolina, it's going to be 90 or more degrees Fahrenheit. The high temperature on Venus today is close to 900 degrees Fahrenheit. It's hot enough to melt lead. Also, the atmospheric pressure is crushing, so you would get squashed. And the atmosphere also has sulfuric acid droplets. That's the stuff in battery acid. So don't go to Venus. Or if you do, make sure you leave behind your last will and testament, because you will not be surviving the trip. Okay, let's clear things out a little bit. And Kim, I'm wondering if we have any questions. We've got a few more minutes.
We have a lot of questions coming in for
great.
you. I am going to ask Mrs. Sizemore's class to come in live with a question.
Okay, and I'm going to stop sharing for a moment, but we can bring it back up if we need to. Okay, and it's Mrs. Sizemore's class?
That's exactly right.
Okay, great.
Mrs. Sizemore, are you able to unmute yourself now? I see a classroom there. Hello, Mrs. Sizemore. You have a question for our presenter, Amy? Hi.
Okay, we have a lot of questions. I think we're getting some feedback too. Raylan would like to know how stars are made.
Ooh, that's a great question. Thank you for that question. Okay, so stars, like let's talk about our star, the sun. So what we think happened is that there's a big cloud of dust and gas, and it eventually collapses under its own gravity and ends up becoming the stuff becomes the star, and then some of the leftover stuff can become planets and moons and asteroids. So, and I can actually, let's see, it's going to be a little dangerous for me to try to do this live here, but let me see if I can show you a place where stars are being born right now. So I'm going to have to do an illegal planetarium move, which is I'm going to have to go back in time. And what I'm going to do is take us back, see if we can get to Orion again. Okay, let me get back here. And there's Orion. And so kind of right in, there's sort of like his belt right there. Hanging down from the belt is a sword. And in that location is something called the Orion Nebula. And it's a stellar nursery. It's where stars are being formed out of clouds of dust and gas right now. So thank you for that question.
Fantastic. We also have a question from Mrs. Law's class, who wants to know, can you talk a little bit about Andromeda Galaxy?
Ooh, the Andromeda Galaxy. Okay. Again, always dangerous to try to drive Stellarium live when you're not prepared for it. Let's see if I can just bring it up. So the Andromeda Galaxy is, you can actually see it. It's also called M31. So that's what I'm going to search for. Ooh, okay. We're going to have to change the time so that we're going to have to go back in time. Okay, so as we can see, it's not a great time to see the Andromeda Galaxy. It is up in the daytime, but let's see what happens. I don't know what's going to happen if we zoom in. I think we're just not going to be able to see anything. Yep, that's not going to work. But the Andromeda Galaxy, oh, as you can see, poor Andromeda, she's standing on her head. So a galaxy is a collection of stars. It's like a city of stars. So we live in the Milky Way galaxy. All those stars I just showed you at night, the sun, the stars you see when you go outside, they're all in the Milky Way galaxy. The stars that you can see are actually only a small fraction of the 200 billion or so stars in our galaxy. But there are other galaxies as well. And some of them you can actually see with just your eyes if you go out at the right time of year and you have a clear, dark night in one of those galaxies. And this is not the right time of year. You have to wait for Earth to move in its orbit around the sun. But one of them is called the Andromeda Galaxy because it's in the direction of the sky that we call Andromeda. But it's much further away than any of the stars in Andromeda, the Princess, because it's a whole nother collection of stars. It's 2.5 million light years away. So if you see that little fuzzy patch of the Andromeda Galaxy, you are looking 2.5 million years into the past, which is pretty cool. Okay, I'm gonna stop sharing and see what other questions. What else do we have, Kim?
Yeah, you have so many questions. Paige wants to know, how many moons does Saturn have?
Oh my gosh, I have to get my Saturn moon cheat sheet because it's hard to keep up. It looks like the current moon count, known moons for Saturn, is 82, which, by the way, just edges out Jupiter at 79. But, stay tuned. Sometimes we keep discovering new moons. Great question. Thank you.
Yeah, and Jonathan wants to know if every planet has moons.
Oh, great question. Does every planet have moons? No. Poor little Mercury and Venus. They have no moons that we know of. Yeah. So you don't always get a moon just because you're a planet.
And Miss Seidenberg's first grade class wants to know, how many stars are there?
Oh, we have a whole planetarium show about that question. Bring your kids on a field trip and see Magic Treehouse Space Mission, and they spend minutes answering that question. So how many stars are there? There's different ways you can answer that question. The show, by the way, gives the answer of 10 billion trillion and 7, but they're just joking about the 7. But you can think of it in terms of how many stars can you see. So at night, if you're lucky, you might be able to see up to about 2,000. Stars in our galaxy, our collection of stars that we live in, roughly 200 billion with a B. But the thing is, there's billions of galaxies. So it turns out to be many trillions of stars. Great question.
Right. And on the star theme, both Ms. Foster's class and Ryan and Ms. Sizemore's class wants to know, who gives the stars and planets the names?
Oh, that's great. Yeah. So the planet names that you're familiar with were named a while ago, and generally from Roman gods. Stars also have names. A lot of them have Arabic names. That part of the world was doing some really great astronomy, and a lot of the stars got named with Arabic names. The way that stars get named now is also, they tend to have really boring names for the most part, like catalog numbers. But the only internationally recognized authority for naming things in space is the International Astronomical Union. These are the same people who demoted Pluto, by the way, in 2006. Now, if you want to, you can name a star yourself. It's just nobody else will agree to call it that. But, you can name a star after yourself if you like to.
Ms. Seidenberg's first grade class wants to know, why are stars different colors?
Oh, great question. So the color of a star indicates its surface temperature. So like if you think about like a flame on a gas stove, for example, if you've ever seen, you might notice that the blue part of the flame is actually the hottest and the red is the coolest, still too hot to touch. And it's similar with stars. Red is a relatively cool star and blue is a hotter star. So Betelgeuse and Arcturus, for example, are kind of reddish orangish. They're relatively cool stars.
Ms. Seidenberg's first grade class wants to know, what is the farthest star from us?
Oh gosh, well, billions of light years away. Yeah, really, really far away. Now, in terms of that you can easily see with your own eyes, I would say some of the stars in Orion are actually pretty far, but Deneb, which is a star in a pattern known as the Summer Triangle, is on the order of 1,000 light years away or so.
Here's a fun one. Someone from Miss Seidenberg's first grade wants to know, has there ever been a cat in space?
Oh gosh, there have been animals in space. Sorry, I'm not up on all the species. We'd have to look that one up.
That was a fun one.
Yeah, there you can imagine cats in the sky though, because there are some constellations that are like Leo the lion and lynx, which is a type of cat.
Sawyer from Mrs. Sizemore's class wants to know how the sun was made.
Okay. Oh, so we talked about that a little bit earlier. So out of a big cloud of dust and gas, and the sun is very old, 4.6 billion years old. It's a middle-aged star. It's got about 5 billion years left on the odometer. So we don't need to worry about the sun anytime soon.
Silas wants to know what the oldest star is.
So stars started forming fairly soon after the Big Bang. The universe, there's pretty good evidence that the universe is 13.8 billion years old. So the oldest stars are, on the order of 13 billion years old.
We have had so many great questions. Unfortunately, we're running out of time. I think we have time for one more question. And so I'm going to ask the question from Kathleen Childress. How did people come up with the idea that stars represented people or animals?
Oh, yeah. So, when I think we all love to look up at the sky and make up stories about what we see, and we tend to honor things that are important to us. And so if something's important to your culture, then you may give it a place of honor in the sky. And so, animals and people are very important to us. And I want to encourage you all to look up at the sky tonight or on your next clear night. North Carolina, we think, has the biggest statewide star party in the entire universe for the public. And there are 35 star party events happening for the public tonight, Friday, April 8th, and tomorrow, Saturday, April 9th. It happens every year, the statewide star party, and you can find information about that at the North Carolina Science Festival website, ncsciencefestival.org/star party. And Jonesville Elementary, we were trying to figure out what was the closest star party to you. For example, there's one at Pilot Mountain State Park, but hope you all will go out and try to find a star party tonight or Saturday night.
Yes, and I also just put a couple of URLs in the chat, one of which is how to find a star party near you. Amy, any concluding remarks?
Just go out and hope you will look up at the sky and maybe make up your own stories about what you see.
Fantastic. And thanks to everyone so much for joining us today. What a great presentation from Amy. We love for you to come visit her at Moorhead Planetarium and Science Center in Chapel Hill sometime soon. She will tell you many, many, many more things about stars. We would also give one last shout out to Jonesville Elementary School, the Blue Jays from Yadkin County. We also want to thank Biogen Foundation and the rest of our NC Science Festival sponsors for making this program and many other things across the state this month possible. And remember, you can find more fun programs like this all month long at ncscifest.org. Thanks so much and have a great day.